Assalamu alaikum students. As we studied Boyle's law in our previous class. Okay, today our topic is Charles' law, page number 101. In 1787, French scientist Charles proposed his law to explain the relationship between volume and temperature. Relationship between volume and temperature. Now, keeping the pressure is constant. Pressure is constant. He gave the definition of Charles' law. That is, the volume of a given mass of a gas is directly proportional to the absolute temperature if the pressure is kept constant. Its mean V directly proportional T. Now, what is the meaning of this sign? It shows the relation. It shows the students relation directly between two things. Now, one thing is volume and other thing is temperature. When one thing increase, the other one as well. One thing is increase, one relation is increase, and other one is also increase. It means these are directly proportional. One thing is increase, now volume, and other thing is also increase, this is temperature. Now, it means these are directly proportional. V directly proportional T, or V equal to KT, where K is proportionality constant. Then when temperature increase, the volume also increase. The temperature increase, volume also increase. Is that clear, students? V directly proportional to T. Now, what is the meaning of this sign? This sign is mean that relationship between volume and temperature, pressure kept constant. Is that clear? Acha. Now, for example, suppose there are two jars. There are two gas jars. There are two gas jars. Heat is high, temperature high. Heat is low, temperature low. Pressure constant. There are two jars gas. One of them is at low temperature. And other one is high temperature. Students, clear? One of them is low temperature and other one is high temperature. Okay. The jar with high temperature is having high or increased volume. Is having high or increase volume. The other one is having the low temperature. The other one is, students, Having the low temperature, it means it has low volume. It has low volume as well, because particles of gas are not moving freely. This is why temperature is low, because particle is not freely move. This is called temperature is low. So it is called Charles law. I hope student is that clear. Mathematical representation of Charles law. This V directly proportional to T. Now V is equal to KT, K proportionality constant. Now this is the numerical. This is the numerical as 5.3. Numerical is 5.3. A 600 milliliter sample of a gas is heated from 27 degrees centigrade to 77 degrees centigrade at constant pressure. What is the final volume? Now we are starting the example 5.3. Example 5.3. A 600 milliliter sample of a gas is heated from 27 degrees centigrade to 77 degrees centigrade. First of all, Celsius change into Kelvin. First of all, degree centigrade change into Kelvin at constant pressure. What is the final volume? T1 equal to 27 degrees centigrade. Celsius change into Kelvin. Now formula of 27 plus 273 Kelvin equal to 300 Kelvin. T2 is 77 plus 273 Kelvin equal to 350 Kelvin. V1 is equal to 600 milliliter. Now find the final volume V2 by using the equation. Using the equation V1 over T1 equal to V2 over T2. We have to find V2. V1 over T1 equal to V2 over T2. V1, it's mean that initial volume. T1, it's mean that initial temperature. V2, it's mean that final volume. T2, it's mean that final temperature. We have to find V2. Now we have to find V2. V2, the formula is V1 multiplied by T2 over T1. It means V2 equal to V1 T2 over T1. Now put the value of equation. V2 equal to V1 value 600, T2 value 350, T1 300, 600 multiplied by 350 divided by 300. V2 equal to 700 milliliter. Volume unit is milliliter. Now the volume will become 700 milliliter, which shows increase in volume with raising the temperature. Student, is that clear? Now that's it. Assalamu alaikum students. We are going to solve section D numericals, page number 119. 119 section D numericals. Convert the following units. Question number 1 is convert the following units. Now convert the following units. The question is 100 Celsius to Kelvin. The question is 100 Celsius to Kelvin. Now we have to find out temperature in Kelvin. We have to find out temperature in Kelvin. First of all, data. Temperature in Celsius equal to 100 degrees centigrade. Temperature in Kelvin, K equal to question mark. We have to find out temperature in Kelvin. Students, clear? Now the formula is, next process is formula K equal to 273 plus Celsius. Kelvin equal to 273 plus Celsius. Now Kelvin equal to 273, Celsius is 100 degrees centigrade, 100 degrees centigrade. Now K equal to 273 plus 100, 373. Unit is Kelvin. Okay students, I hope you understand. K is equal to 373 Kelvin. Now the B is 150 Celsius to Kelvin. Now C is 780 Kelvin to Celsius. Question C is 780 Kelvin to Celsius. Now, first of all, data, we have to find out temperature in Kelvin, means Celsius in Kelvin. Now, we have to find out Kelvin in Celsius, Kelvin in degree centigrade. First of all, data, temperature in Kelvin. Temperature in Kelvin equal to 780, unit is K. Now next is temperature in Celsius, degree centigrade. We have to find out, question mark. Formula is Celsius equal to K Kelvin minus 273. It's mean 780 minus 273. The answer is 780 minus 273. 780 minus 273, students, 507 Celsius. The answer is 507 Celsius. Now students, you understand? 780 Kelvin to Celsius. Now 100 Celsius to Kelvin. First of all, we have to find out temperature in Kelvin. Now we have to find out Kelvin in Celsius, means degree centigrade. Section D, numerical. A, C is done. A, C is done. Now page number 119, section D, numerical, question number 2. Question number 2 is, it is desired to increase the volume. It is desired to increase the volume of a fixed amount of a gas from 90.5 to 120 centimeter cube, while holding the pressure is kept constant. What would be the final temperature if the initial temperature is 33 degrees centigrade? Students, first of all, 33 degrees centigrade means 33 Celsius. We have to find out temperature in First of all, Kelvin. Section D, numerical. Section D, numerical 2. Acha. Now, data. First of all, data. It is desired to increase the volume of a fixed amount of gas from 90.5 to 120 centimeter cube. 90.5 to 120 centimeter cube. It's mean V1 equal to 90.5 initial volume, V2 equal to 120 centimeter cube final volume. V1 initial volume, V2 final volume. While holding the pressure constant, pressure is constant. Now what would be the final temperature? What will be the final temperature, students? Final temperature is T2. We have to find out T2. Now initial temperature is 33. Initial temperature is 33 degree centigrade. Now 273 plus 33 degree centigrade equal to 306 Kelvin. First of all, we have to find out temperature in Kelvin. Now, solution. Formula is the formula of Charle's law will applying here. Formula is V1 over T1 equal to V2 over T2. V1 value 90.5. T1 value 306 Kelvin equal to V2 120. Now we have to find out T2. It's mean final temperature. 90.5 divided by 306 is equal to the 0.295. 120 over T2. Now here 120 is dividing. Now opposite side multiply equal to T2. T2 equal to 35.4 Kelvin. This is answer, student. Now formula is V1 over T1 equal to V2 over T2. The formula of Charle's law will apply here. Formula of Charle's law will apply here. V1 over T1 equal to V2 over T2. V1 value 90.5, T1 value 306. Celsius to Kelvin. Celsius change into Kelvin. Now V2 value 120. T2 we have to find out T2. 90.5 divided by 306 Kelvin. Now the answer is 0.295. 120 over T2 120. Here we dividing. Now opposite side is multiply. 0.295 multiplied by 120. T2 equal to 35.4 K. Students, clear? That's it.